Example 11. Find the acute angle of intersection between two planes 2x minus 4y plus 4z equal to 6 and 6x plus 2y minus 3z equal to 4. This is how we visualize the problem. The first plane is given by 2x minus 4y plus 4z equal to 6. So there is a vector perpendicular to the first plane. Let's call this n1. And then the second plane is given by the equation 6x plus 2y minus 3z equal to 4. And the vector perpendicular to the second plane, the normal to the second plane, is called n2. We are going to find the angle between these two planes. And we want to get a smaller angle, acute angle less than 90 degrees. First, we note that the angle between two planes is the same as the angle between two normal vectors n1 and n2. Now, what is the direction of n1? It is equal to the vector in the same direction as 2, -4, and 4. And what is the direction of n2? You can get them by looking at the coefficient of the plane, which is 6, 2, -3. To find the angle between n1 and n2, you can use a dot product to find it. Recall that n1 dot n2 is equal to the length of n1 times the length of n2 times cosine theta, where theta is the angle between n1 and n2. Now let's compute n1 dot n2. This is equal to 2 times 6, you get 12. Minus 4 times 2, you get minus 8. 4 times minus 3, you get minus 12. Total is -8. Now let's find out the length of n1, which is square root of 2 square plus -4 square plus 4 square, which is equal to 6. Similarly, you can find the length of n2, which is equal to 6 square plus 2 square plus -3 square. And then you take the square root, and you find that the length of n2 is 7. Now we substitute the dot product of n1 and n2 equal to -8, and the length of n1 is 6, the length of n2 is 7, and we find that cosine theta is equal to -8 over 42. This means the angle theta between two vectors n1 and n2 is 100.98 degrees. And this is a diagram illustrates the angle between n1 and n2, which also means that the diagram we have earlier, the direction of n1 and n2 needs some adjustment. If I keep n1 pointing upwards from the first plane, then n2 should be pointing downwards from the second plane. Then you can see that the angle between them is 100.98 degrees. From here, we can find that the angle theta, the acute angle between two planes, is 180 minus 100.98 degrees, which is equal to 79.01 degrees. This will give you the angle between these two planes.